The debate between hardware or software RAID can get some people quite emotional. However, both approaches work and each has its own strengths and weaknesses. Let's look first at hardware RAID. First up, hardware RAID uses dedicated hardware. This picture in the slide shows a PCI hardware RAID controller that will fit inside of any industry standard server. It's a PCI expansion card, and it's because of this dedicated hardware that hardware-based approaches to RAID tend to be viewed as high performance. This approach doesn't steal any host CPU cycles or memory, and it doesn't negatively impact applications running on the host. Also on the topic of performance, hardware RAID controllers often have an NVRAM cache that significantly speeds up performance, especially write performance. Although you will want to make sure that this cache is indeed non-volatile, meaning it won't lose data if the electricity supply to it fails. Non-volatility is usually achieved by either using a small battery or supercapacitor that will keep power to the RAM for a while, during which time you need to restore mains power. These systems are known as battery-backed write-back caches, or BBWC for short, and another and increasingly popular way to achieve a non-volatile cache is to use flash memory as a cache. Flash by its very nature is non-volatile, and these systems are known as flash-backed write-back caches, or FBWC for short. So, hardware-based RAID is seen as high performance. Its downside, though, is cost. Good hardware RAID controllers, especially those with decent amounts of NVRAM, cost decent money. So that's one drawback for some people. Another potential drawback for hardware RAID controllers is they tend to be less flexible than software RAID. So let's take a minute to talk about software RAID. Software RAID has historically been seen as a poor man's RAID. RAID for those who can't afford a hardware RAID controller. And because it doesn't have its own dedicated hardware to perform the RAID-related functions, it has to steal resources from the host CPU and RAM, potentially starving your applications of CPU cycles and the likes. And while this can be a problem, it is becoming less of a problem these days, as most modern servers have lots and lots of cores and often have spare CPU cycles. Also, software-based RAID is becoming more popular due to the recent industry push towards software-defined everything. And software-based RAID is technically a form of software-defined storage. And software-based RAID approaches are undoubtedly getting better all of the time and offer flexibility that hardware RAID controllers can't. Another limitation of software RAID is that it can't be used to RAID protect an operating system boot drive. This is because the RAID software needs to be loaded in order to read data from a software RAID volume. But in order for the RAID software to be loaded, the operating system needs to be booted up. But the operating system can't boot up because it can't read the contents of the software RAID volume. Essentially, the OS needs the RAID software to be loaded in order to read data from the OS boot drive, but the RAID software needs the OS to be booted before it can load, a proper chicken and egg situation. It's also worth pointing out that it's quite common for software RAID to be used to create a RAID 0 stripe on top of volumes that are already RAID protected by hardware RAID controllers. But it's still very uncommon for software RAID to be used to implement parity, mainly due to the overhead on system resources that parity calculations impose. Now another form of hardware RAID is the external storage array.